actually one of our
that's a linear equation, folks. That is a linear equation, and as you well know, it's linear because it's only a power of 1 of both variables. Now, a couple of things you have to know about these things. First of all, this is a linear equation written in general form. Written in general form, okay? And I'll go over some reasons why you need to write it or be able to write it in general form. A couple of things I want you to take note of and not ever forget, and that is this. First of all, you do not see any fractions in this problem. There are no fractions in this problem. The first variable that comes in the problem will always be the x variable. It will always be positive. If it's not, you better make it positive. You better just change everybody's sign and make that a positive. Right here. I don't care about the rest of them. The y's come next, and then the number has to be equal to 0. Now, again, that's just saying that what? There's no fractions, absolute no fractions. The x term comes first, is positive, and it's equal to 0. All right. Second type of problem is this. It's called, let's put this in standard form. Well, putting it in standard form is really simple because all you have to do is put the 3 on the right-hand side. Just 6x plus 3y is equal to 3. Now, there will be reasons for you having it in this format, okay, called the standard form. And this is going to be advantageous when you have been given a set of systems of equations. In other words, 2 equations and 2 unknowns. And they're going to want to know where they intersect, or if they do actually intersect, okay? But let me show you something real quickly here with this right here. This is something that's, the books usually don't tell you this, but you could actually stop right here and do something real quickly, because certainly you cannot look at this and tell me what it looks like other than it's a line. You don't know whether it's a line going this way or this way. But what you can do, and you can do this real easy, is this. What if I make x 0? If I make x 0, y is equal to 1. That's as simple as falling off a log. Then I could come back and I could say, let's let y be 0. What is x if y is 0? 1/3. Is that 1/2? I mean, yeah. Is that correct? Yes. 1/2. So now, look what you have. You have 1/2, that point, and you have a 0 and a 1. So guess what? You know that that line looks like that. That makes sense? Does that make sense? So they don't usually tell you this right here. They want you to do what? They want you to put this in slope intercept form and then graph it. Okay? You could do that if you wanted to. To put this in slope intercept form, it's just a matter of solving this equation for y. 3y is equal minus 6x plus 3. Y is equal to minus 2 x plus 1. So this equation right here fits that line. And it's quite obvious because it has a negative slope and it goes through positive 1. Everybody see that?
Yes.
So they generally want you to take this equation and put it into slope-intercept form to graph it. But you really don't have to, because I graphed it when it was wet in this form right here. Okay? Now, that's the three forms. This is used for what? Graphing purposes. This will be used for a multitude of purposes, especially when you get to systems of equations, and they're going to ask you, do these two equations cross each other? Okay? They're going to give you two linear equations and ask you where they cross, or if they, in fact, cross. How about this form? They're called the general form. You've not seen, up until this point, the reason for this form. You've just not seen a reason for this form. I am about to show you a reason for this form right here, okay? And I'll use this exact same example to show you why it's important. Because listen, they very well may give you this equation in this form. Can everybody see the slope-intercept form? Everybody see that, or you want me to write it somewhere else? Is that too low? Can everybody see it? They may give you this equation in this form. And they very well could ask you this question. Everybody see that point up there? Do you see that point? And I've labeled it for you. I've labeled it 5, 6. I'm just assuming that's about where it's located. The question could be this: how far is it from that point to your line that you have drawn? Now that could be sounding like a loaded question, because are they talking about down to here? Are they talking about going over here somewhere? Where exactly are they talking about? Well, this is where they're talking about. They want you to take the shortest path from this point to this line. They want you to find the shortest path from that point to the line. Now, I may not have it exactly labeled exactly right. 1, 2, 3, 4. That may be 5, 5. I don't know, but whatever. But whatever the case may be, that very well may be the question. Well, if it is the question, then the answer is quite easy, because the only thing you have to remember is this. That, the distance is equal to the absolute value all divided by Now, that's quite easy to see, because all this means is what? This is the linear equation in what form?
General.
In general form. And do you see where you get the A from? The A is this number right there. You can certainly, it's called arithmetic from this point. It really, really is. Now what I will do is I'm going to replace this general one right here with our original one we're talking about over there. And I think it's what? 6? What is it? 6x, right? Plus 3y minus 3. And do you see the absolute value signs? Mm-hmm. The reason why, the only reason why the absolute value signs are there is because the distance from a point to a line can never be negative. And you very well may get a negative number on the top. You won't get one on the bottom, but they're all squared. You see it? They can be negative. You square them, they're going to be positive. That bottom number will always be a positive number. But the top number, very well, it's according to where your point is located, may very well come out to be a minus 250. How are you going to deal with a minus 250? You got to make the absolute value come into play. It becomes a positive 250. Does that make sense? That's why you see the absolute value signs around the problem. Well, this now becomes what? This, everybody. This becomes what? 6 squared, right? And this becomes 3 squared. Are we okay, everybody? Everybody follow what I'm doing? You don't want to lose anybody. But guess what? What about the top up here? What about this x and y? Guess which one we're going to use? This is the x, and that's the y. So we're going to go put those in to the problem. The x is what? 5. And the y is how much? 6. And now we just do the arithmetic there. 5 times 6 is 30. Plus 18. Minus 3 divided by square root of 36 plus 9 is how much?
45.
35? 45? Now, you can, how much this is? How much is this top one?
45.
The top one is 45? And notice I just released the absolute value signs because it's already positive. Now this can be written as what? Does everybody see I could write the 45, the square root of 45 is 3 onto the square root of 5. Because what's 45? 5 times 9 is 45, right? What's the square root of 9? 3. So I bring the 3 outside. Everybody still with me?
Mm-hmm.
So now you could actually do what? This becomes 15 over what? Are we through? No. Why not? You want to do what?
Move the radical.
You want to rationalize the denominator.
Multiply it.
So that means multiply the top and the bottom by the square root of 5. So the bottom becomes 5. And look what happens. This cancels. So now we get what is an answer. So you may get all sorts of different answers, and the answer given to you may be this. You got to make sure you can take it down to that level. Is everybody okay with that? Okay? Everybody okay? Well, I'm not. Because I've got one more problem to include here. And they very well may ask you to do this, and that's this. Who wrote on my? Did I put this up here?
You've been that good weekend.
Can I erase this out and leave this alone, Howie? See, I lost my point. My point is up here. So the distance is what? 3 onto the square root of 5. But you could say 3 times the square root of 5. I don't care how you say it. But that's the shortest distance from what? From this point to the line. So the question may be, so you do have the distance between the point and the line. That's good that we know that distance. That would be very, very important in a surveying problem. They got a point and they got a line that they've already run a line somewhere. They want to know the distance from that point to the line. We just found it, okay? But what about if they ask you this question? Write the equation of that line. I don't want to know the distance anymore. I'm tired of talking about the distance. I want to know the equation of the line from that point down to this line. How do we get that? You have to listen to me carefully because it's real, real simple. You have a point, right? There's a point right there. And that point lies on this line that we're talking about. But guess what else you know? You also know the equation of this line, right? Mm-hmm. And the equation of this line happens to be this. Yes or no? Yes. Well, listen to this. The equation of your other line, its slope has to be opposite in sign of this one and the reciprocal of this slope. So here is the perpendicular because this line is perpendicular to this line. That's what it meant. The shortest distance would have to be a perpendicular line. So the perpendicular line has to be y is equal to 1/2 x plus some value b. Plus some value b. The only thing missing now is the value of b. And guess what you have? You have a point up there. You have a point, 5,6. That's on this line right here. It's on this line. So all you do to find b is to do what? Let's just plug in the x and the y value up there. Y is 6. X is what? 5. This says that, let me get up here, 6 is equal to 5/2 plus b. B has to be equal to 12/2 minus 5/2. B has to be equal to what? 7/2. Is that correct? 7/2?
That's right.
Did I do the arithmetic correctly?
You did.
Mm-hmm.
So, that point, even though it may not look it, this point right here is 7/2. 1, 2, 3, 4, that's what? 3.5 right there. One goes up here somewhere. 1, 2, 3, 3.5. Like I said, it's hard to draw the things when you're just drawing a freehand line. Now, why would you want to know the equation of that line? For what reason would you want to know the equation of that line? Just to punish you all, to make you find it? No.
It makes a 90-degree angle. It makes a 90-degree angle.
Yeah, we don't. Yeah, it has to make a 90-degree angle. We know that.
You can find point of intersection. Point of intersection.
Right. You may be asked, where do those two lines cross each other? Where do they cross each other? At what point do they cross each other? And all you'd have to do that is to do what? Is to set one equation equal to the other one. And when you do that, you're going to get an x value. And then from that, you can find the y value. Does that make sense what I just said? You could set those equations equal to each other because that's what you're looking for. Where are they equal to each other? So, is that okay? That makes sense? So there's many applications for this type stuff. Now, I'm not going to go and set these two equations equal to each other to find this point because it may be quite it may be ugly because it may involve a bunch of fractions and decimals and whatever else. So, but what's nice is when they make up some really nice ones that do what? They cross each other at integers. It's really, really neat to know that. So, everybody see this? These two lines are what? Are perpendicular to each other. And the reason why is because they're opposite in sign, slope is opposite in sign, and the reciprocal. And all that says you all is this, that M1 can be the slope of the first one, and M2 be the slope of the second. That has to always equal what? If you multiply the two slopes together and you get a -1, and that tells you that they're what? They're perpendicular. If one slope multiplied times the other slope is equal to -1, then the two lines are perpendicular. This is not for this class, but it's just for your own interpretation or whatever, but they could be called that those two lines are perpendicular to each other. Those lines are orthogonal to each other, or those two lines are normal to each other.
Spell the second word you just said.
Orthogonal.
Orthogonal.
Orthogonal. Now, those are just terms that you may hear. You will hear the term normal quite often in physics, because in a physics problem you may have something like this. You may have an inclined plane like this. You may have a box sitting on this inclined plane like this. And the weight of this box is actually projected towards the center of the earth, straight downward. That's the weight of the box. There are two other forces involved in this thing. And there's something called a normal force, which is here like this. Now, if you ever have any doubts about this force, called the normal force, then what I'll have you do, for the ones of you that question this, that this box is 500 pounds. Then I'll have Mr. Wilson back there pry it up on one side, and you stick your finger under here. And you tell me if there's a normal force pushing on your finger. And I'll bet you will agree that yes, there is a normal force pushing against the what? Perpendicular to this what?
Plane.
To this inclined plane. Does that make sense? And they actually label this as the normal force. F of N means it's what? It is perpendicular. It is acting perpendicular to the plane. It's quite obvious if you stick your finger under that 500-pound block, you will know that there is a normal force acting on your finger. And of course, you don't have to write this down because this will come probably later in this course. But you probably need to know this. But you know there's a force that's acting down, trying to make that box slide down that plane, right? Because if that's a block of ice on an ice inclined plane, it's not going to stay there. It's going to do what? That force is going to make it go down the hill. But if you take notice of this thing, we know for a fact that you can do this in physics. You can move these vectors. These are called vectors. You can move them, provided you don't change the direction nor the magnitude. That means the length of it or the magnitude of it, the value of it. As long as you don't change that value, I can literally slide this down to right here. And guess what I've made? I have made a 90 right triangle. That's all you've made. And you all have studied 90 right triangles in this class. You have studied 90 right triangles in the Math 1111 class. You know how to get the value of the other sides. If you, a squared plus b squared is equal to c squared. But this actually even becomes fairly easy because let's suppose that box is 500 pounds. 500 pounds is a box, and that is the hypotenuse. Look at that and see if that's not the hypotenuse. Certainly is the hypotenuse. And here's the neat part about it. And let's suppose that this is a 30-degree angle. What if that's the 30-degree angle on an inclined plane? Guess what this angle has to be? It has to also be 30. Do you see why? Do you see why this is 30 degrees also? If this is 30, then this angle right there has to be what? 60. Am I correct? This is a 90-degree angle. So if that's 60, then the other one has to be what? It has to be 30. So whatever angle the inclined plane is, has to be this same angle right there. Now, I'm going to stop at that point because we won't get into this until a little bit later in the course, where you will be able to calculate. This is called the frictional force, by the way. That's the frictional force acting down the plane. In other words, you have a force that's trying to make that box do what? Slide down the plane. You have a normal force that's doing what? Pushing against this thing. And you have the hypotenuse, which is the weight of the thing, which is pointing straight to the center. From the center down to the center of the earth. So, here's the thing about it, folks. What is the determining factor that keeps that block in place? Besides its weight. We know the weight has a somewhat to factor in whether it stays there, right? But you have to think about something. What determines its factor of whether it goes down that board or not is something called coefficient of friction. And they have done this over and over and over again. They have calculated for you, and they put it in engineering books, coefficient of frictions. Wood on wood has a coefficient of friction of a given number. Teflon on Teflon has a given number. It's quite low, a very low number. Rubber on cement has a coefficient of friction. Rubber on asphalt has a coefficient of friction. Period. So it determines what is the coefficient of friction. Coefficient, yes.
Are you referring to mu times the constant?
Well, yeah, actually it's this. Mu is the coefficient of friction. And it is the frictional force divided by the normal force. Mu is the fixed value. You can find that number in a textbook, in an engineering textbook. If that's wood on wood, or suppose that's concrete on concrete, then that mu value is going to be pretty high. What you should recognize here is this. You know what this is, don't you? Who knows what this is?
Force of friction over force.
It's what? Who knows your trigonometry? That's the tangent of the angle.
Yeah.
The tangent of the angle is opposite over the adjacent. So guess what? When mu is greater than what? The tangent of the angle, it's going to stay up there. When mu is less than the tangent of the angle, it's going to do what? It's coming down. Unless you push it up there and hold it up there.
What if they're equal? What if they're equal? What if they're equal? Like, what if mu...
I don't think they'd ever be equal. There's going to be a slight difference between the two of them.
Okay.
But if they're equal, they may do what? They may slide or may stay there. You know, one or the other. They could...
So you think that could be like tectonics? That could be like plate tectonics.
Yeah. But that's like looking at the concept of tires on a car, for example, is the coefficient of friction is set for what? For rubber on asphalt. So, have you ever thought about why do they put great big wide slicks on race cars? Tell me, why do they put great big wide tires like this wide on dragsters? Because why don't they put treads on them? What are treads for on a car? What are treads for on the wheel of a car?
Water,
To do what?
disperse.
To displace the water only. That's all they're good for. You can't change the coefficient of friction in a normal way. So why do they put big wide slicks on race cars?
Increases the coefficient of friction.
Is what? How? How?
You've got more surface area touching.
How? What?
Add more surface area.
No! 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 I just finished telling you that rubber on what? Asphalt is set. I don't care. Hell, who got a book?
We don't have a book for this class.
Does it? Is it better if I push it this away? Or this away?
What?
Or this away? No. No. Still takes the same amount of force to move it. I don't care if you stand it up, lay it flat, or whatever. Same thing with rubber on tires. The only reason that they put the wide tires on the race cars is to change the coefficient of friction, and the only way they can change the coefficient of friction is what? Doing what they call a burn off. You change the temperature and you change the coefficient of friction. If race cars were not allowed to spin their wheels, then you might as well put the little tiny bicycle wheel on your race car, because you would win. If you're not allowed to spin your wheels and to do what? Heat up the rubber against the concrete or the asphalt to change the coefficient of friction, then you might as well run little narrow tires the size of my little finger, because they would be a lot easier to turn. Is what?
I was just telling you the best tires to get would be Kumatuma tires, and they gotta be run flat. And I heard that song before.
Hell, is that a rap song?
Kumatuma tires, and they gotta be run flat.
I've never heard that song. No, me neither. I've never heard that song.
You haven't heard it?
No.
I haven't either.
So, when I first had put the truck with,
But that is something that you have to think about, because changing the size, the width of the tire does not give you more gripping area. It does do what? It gives you more area to cover that makes the tires what? Hotter. When those tires spin, they do what? They look like oval shapes like this. They almost come off the thing, so. But anyway, I thought that'd be worth knowing, so I don't know what for. But this determines right here is the coefficient of friction between these two plates right here. And if that mu value, that's what that's called, by the way, coefficient of friction is labeled mu. And you can look that up in Google or whatever and do what is the coefficient of friction of wood on wood. It's actually hardwood on hardwood. They got all different types of wood that they've done what? That they've actually experimented with over and over and over and over, probably tens of thousands of times, to calculate now, you're going to find that there's two of them. There's something called static friction, and there's also friction of motion friction, and that is the static friction is the value that it takes to start it moving. And you know as well as I know, it takes more force to get something moving than it does to keep it moving. And that extra value that it takes to get it moving is called the static frictional value. Now, not that you have to know this now, it may be necessary that you know this later, but since I have the picture drawn up here for you, it's quite easy if you have a calculator to determine the coefficient of friction, which is right here. I mean, this value right here. You can get this value. You can find this value, this called the frictional force. You can get this value right here with the information you now have. As a matter of fact, it is this value right here, the 500 pounds, multiplied times the sine of this angle gives you this, which turns out to be 250. I just happen to know because I know that the sine of 30 degrees is 0.5. And then you define this value here, it is 500 multiplied times the cosine of 30 degrees, which is 0.86 times the what? 500. So y'all do that multiplication real quickly. 500 times
433.
433. So there's the two forces that's acting down on that block of 500 pounds sitting on that inclined plane. So you could actually do this. You could do this value right here, 250 divided by the 433. Somebody do that calculation real quickly.
0.58.
Point what?
58.
It's 0.58. So the mu value right now is 0.58.
That's crazy.
So this says what? If the tangent of 30 degrees, somebody calculate the tangent of 30 degrees real quickly. Just punch tangent and then 30 degrees.
0.58.
So that's
0.58.
0.58. So in other words, right now the way it stands is what? They're sitting there right now, they're sitting still. Because you may well look up and you may find out that what? You may find out by looking at a book somewhere that the two materials that you're talking about there may have a coefficient of friction of what? A 0.25. That block is not going to stay up there, folks. that coefficient of friction is too low for it to stay there. Somebody Google, coefficient of friction, or just do coefficient of friction. And it may give you a table of some coefficient of frictions, like wood on wood. See what the coefficient of friction of hardwood on hardwood is. Get it? Damn it, y'all, let me see what y'all got on your machine. So, yeah, you got off of it, huh?
No, it wasn't on anything.
You just like
Hey,
the
so-
screen? Yeah.
So what if you like, the tangent of 30 degrees is also the square root of 3 over 3. Tangent of 30 degrees, isn't that also the square root of 3 over 3?
Well, you checked out.
I mean, I'm just going by memorization of the unit circle. That's all I was going by. Is that on the unit circle, a tangent of 30 degrees is the square root of 3 over 3?
Square root of 3 over 3?
Yeah. So instead of having 0.58,
You could-
if you use
You could very easily check that out by doing this.
you would just make it x squared plus y squared, wouldn't you? Which is the
See
same.
this?
Yeah.
This could be 2, that's 2, and that's 2. That's an equilateral triangle, right?
Right.
And you know that each of the angles are what? 60 degrees, right? That's 60 degrees. That's 60 degrees, and that's 60 degrees. If I drop a perpendicular line, then that makes that what?
30.
30 degrees. That also makes this what? 1 from here to here, right? Anybody see that?
Yeah.
Do you see how this value right here becomes this? This is what?
Yeah.
Does everybody see that the height of that triangle is the square root of 3? Some of you can't because you got your mind somewhere else. I can't help you. I can't do anything for you, like I say, when we get to these sections. If what he says is this, and the tangent of this 30 degrees is this divided by this. In other words, the tangent of 30 degrees is opposite over the adjacent, which is this. So what he did was he did what? He rationalized the denominator, which multiplied the top and the bottom by what? That's where he got that. Does everybody see where he got that at? He memorized it just from the what? The unit circle thing.
Well, I mean, it's just sine over cosine. So, I mean,
Yeah, you do that for the sine, the cosine, tangent for what? 30, 60,
30, 60, and 90. And
45.
I mean, you can use them for when, those values, just depending on what quadrant it is, I mean,
Right.
they'll change, but that's the path you use.
When it's 45 degrees, the sine and cosine of both is 0.707. 0.707. Both of them. Cosine of the angle, the sine of the angle is 0.707.
Which is square root of 2 over 2. Square root of 2 over 2. Right?
Yeah. That makes sense, everybody?
He's gonna want exactly that. He's not gonna want. You can get that though.
Is it almost time to go? Pretty close? It's getting pretty close, isn't it?
2 minutes.
Anybody have any questions about what we did today? Notwithstanding the cement block on the inclined plane, that will certainly come up later on when you get to the section of trigonometry, because this course does require you to do some trigonometry. Any questions so far?
Yeah, I have a question.
Yes.
Okay, so if you had your sine, your cosine, and your tangent of, 30 degrees, or if you had your tangent of 30 degrees, 45 degrees, and 60 degrees, your tangent is going to be the square root of 3 over 3, and that would mean that your tangent would have to be 1, and then your tangent of 60 would have to be the square root of 3.
The tangent of 60?
Yeah, if you took tangent of 30, tangent of 45, and tangent of 60.
Well, this would be what? This would be 45, right? That would have to be what? 45.
Right.
So, the tangent of 45 is 1, because 1 divided by 1 is 1. The sine of 45 degrees is this divided by this. The cosine of 45 degrees is this divided by this. You see this? You see why they're both 0.707?
Yeah, they're both square root of 2 over 2 if you rationalize it.
Yeah, square root of 2 over 2 if you
Yeah.
rationalize it.
Do you want, like, on the test, are you going to want us to use exact value?
Well, it'll depend on whatever the answers are. I don't put in the answers or whatever. But I can remember working with some students before, and they were in mechanical or whatever, machine shop, tube and die folks, and also electronic students at one time. They were using continuously 0.707 and didn't know why. We just always use 0.707. And when I asked them, well, why do you use 0.707? Well, we just been told to use 0.707. Nobody had bothered to tell them that's because you're dealing with a 45-degree angle. The peak voltage is at 45 degrees. And it's the same thing as I showed you one time before this. Now this, for example, this value right here is equal to how far it goes down range, R, is equal to V sub I squared divided by the acceleration of gravity times sine of 2 theta. And that's just fixed. You have no control over that. No control whatsoever. That's what it is. If you want to know how you get this, I will show you soon how you get this, because you won't know how to get it right now, because we have to go into the trigonometry part of this course for you to see how they did this. But it's quite obvious, if you just take a look at it, that the farthest that this will go, unless you change the initial velocity, is when this angle is at what? 45 degrees. Why is that? Because what is 2 times 45? 90. What do you think the side of 90 degrees is? It's 1. The side of any angle will never ever be bigger than 1. So this will never ever be greater than 1. That won't ever be greater than 1, ever. The only time it's ever going to be 1 is when it's 45 degrees. So if you put this at 45 degrees, then this joker's going to go land as far down range as possible. And the only way you're going to change that is by putting more powder bags in your cannon and making the initial velocity faster. Because if you go up 10 degrees to 55 degrees, it's going to do that number. If you go down 10 degrees, which is 35 degrees, it's going to do this number. That's just the way it works, folks. Just the way it works. That's why there's 2 angles. Sine of 2 theta. God, how nifty can that be? I mean, how did the math work out like that? It's just incredible when it's like that. It just does. Sine of 2 theta. Couldn't have worked out any more perfectly. 2 angles. And 2 times 45 is 90, and sine of 90 is 1. It won't ever be bigger than 1. I'm through.